Welcome back. I want to start with our exercise problems we used last time for confidence interval. And we had an example about battery life of iPhone. And we had this information, right? We take a sample, and the sample mean was 991.02. And sample standard deviation was 87.17, and we know that n was 100. Okay, with this, we try to estimate the confidence interval. So the confidence interval, we get x bar plus minus z alpha over 2 and sigma over root n, if we indeed know sigma. But the problem was that we do not know sigma because that's the true value, which is unknown to us. But if n is very large, then we can substitute sigma with s, sample standard deviation. That's okay. But the problem occurs when we have very small sample size. In other words, n is not big enough. If that is the case, we have to use t distribution, and we already practiced how to estimate these t values using Excel and so on and so forth. So that's what we did last time. It was confidence interval. And today, we want to talk about a similar issue, not exactly the same, but very closely related with what we did last time for confidence interval. For example, let's say some people ask us about, is the battery life on average less than 980 hours or longer than 980 hours? Somebody might ask something like this, right? And if we want to answer that question, we probably want to calculate some probability. For example, I probably want to calculate the probability, say mu less than or equal to 980, right? So if I can get this probability, then somehow I think that I will answer the question. Is it true that battery life, the true mean value of the battery life is less than some values? So the first step is to calculate this kind of probability. And let's say there are easy way and more complete yet a little bit complex way. But let me do this in two different ways. First, which is longer and the more complete way to calculate this probability, following all these calculation method we used last time. For example, if this is the case, then I want to multiply -1 on both sides. So we're going to have something like this, right? And then I add x bar here. So let's say probability x bar minus mu, x bar minus 980. And I also divide this two sides by standard error. So x bar minus mu over s over root n. And that's x bar minus 980 over s of root n. And we know that that's sort of p values or t values, right? T values or t statistics, or let's call that t value, and which is 1.2642, okay? And you put this x bar and s and n, you will get this number. Then I can calculate the probability, and the probability is going to be 0.104564, something like that. we already did, how to learn how to calculate this using Excel. So let me give you the formula. It's T-dist. T-dist. And remember, we have two sides. So if I use T-dist, that's about left side. But now we are looking at the upper side. In other words, if this is T distribution, this is 0, and this one actually meaning the 1.2642, and what is the probability here? So T dot dist dot RT, meaning the right tail, and then you put 1.2642, and degree of freedom is n-1, which is 99. So if you use this one, then you will get this probability. So the probability the true mean is less than 980, given this information from the sample, okay? Given this information we get from the sample, what is the probability that true mean is less than or equal to 980? And that's going to be about 10%. Do you think it's big or do you think it's small? Right? You have to think about it. But if someone actually asks us about this question, is the battery life less than 980? Somehow we can answer this question, and we say that, the probability that the true mean of the battery life less than or equal to 980 is about 10%. And then you have to determine, you have to judge whether 10% is big enough or small, or whatever level you believe it is, in terms of making your decision about whether you want to say that the true battery life is less than 980 or not. Okay, that issue is pretty much related with hypothesis testing. Okay, the exercise problem we talked about just before, that's actually is a good example from which we can discuss this topic, hypothesis testing. So why don't we just start hypothesis testing. Sometimes, some people ask some questions like, is it really true that a certain number is less than or equal to something? And, when you say it's true or not, how confident are you when you say that? So in that sense, you can see that the terminology is pretty much similar with the confidence interval, right? You have to determine whether a certain value is larger than or smaller than some other value. And when do you actually accept that statement that something is bigger than some number or something is larger than some other number? Can you really accept that statement? If you really accept that statement, what is your confidence level, so-called? Or sometimes we call that as a significance level. So in hypothesis testing, there are two different types of hypotheses. One is we want to try to confirm. We want to try to prove. So that hypothesis is called H1, which is called alternative hypothesis. And this is something we want to prove. We want to prove and we want to accept, actually. That is something I want to show. And in order to show my statement is right, there is other hypothesis which I want to reject. For example, let's say that's null hypothesis. Null hypothesis. this is opposite. This is opposite of the alternative hypothesis, right? And if we have these two different types of hypotheses, and if we can reject the null hypothesis, that automatically say that we accept alternative hypothesis, which we hope, we want to prove, we want to confirm. For example, think about this. Is it true that the next period demand is larger than 10,000 units? You know, I needed to make a presentation to my boss, and I will tell her that the demand for our product will be larger than 10,000 units next period. Then that's something I want to prove. In other words, what I want to prove in this example is, okay, the alternative hypothesis is the demand. The demand is going to be 10,000 units. That's alternative hypothesis. And then the null hypothesis is the opposite of the alternative hypothesis, meaning that the null hypothesis is the demand. Demand is less than or equal to 10,000 units. And therefore, if I have these two different hypotheses and I collected some data, obviously we use a sampling here, right? I mean that we cannot go out and look at all potential, possible outcomes one by one. So we will use some random sampling and some sampling methods, and we get the sample and we measure some values from the sample, and then using those sample information to measure or to state something about the population. And this is exactly the same process we actually used for confidence interval. If we try to make a decision regarding this hypothesis testing, as I already said, we will use this sample information, in other words, information we derive from sample. So we have X bar, and then we have some distributions. And if, for example, if 10,000 unit is here, let's say this is 10,000, then obviously you can see that we have to decide whether the 10,000 unit is very likely figure or not. That's something we have to tell in order to decide whether we reject the null hypothesis or whether we cannot reject the null hypothesis. And I think that you get a sense about how we should approach this problem. And obviously all these numbers we talked about for our confidence interval will be useful. We will use those numbers. So this is so-called one-tail or single-tail hypothesis, one-tail hypothesis, and that's because we are looking at just one side. In other words, whether it's less than or equal to, larger than or equal to. So that's one tail. We're just looking at the one side. And there is another type of hypothesis testing, which is called two tails hypothesis. We have two tails hypothesis. In that case, the hypothesis will look like this. In other words, let's say the null hypothesis is saying that some variable or some parameter is 0, and the alternative hypothesis is beta is not 0. Okay? If that is the case, what you try to do is, let's say here, This is sample information. So if this is 0, then we have to look at whether the true value is really far away from this value, the 0. In other words, whether it is in the extreme tails or not. So in this case, we have to look at two sides at the same time. In other words, if you far away in that direction, that's still some evidence that may or may not support null hypothesis. Okay? In other words, depends on how far away we may or may not reject the null hypothesis. And likewise, if we far away in that direction, that also is a significant or very useful information we can use to determine whether we reject or we cannot reject the null hypothesis. So we have two different types of hypotheses, and because we already learned the basic, basic theories or basic principles when we learned the confidence interval, there is nothing new here. The terminology will be the same, and basically the logic is very similar, and you will understand the whole thing about hypothesis testing if we work on the exercise problems together. So from now on, I want to go to our textbook exercise problems, and then I will tell you how we can test this hypothesis using all these tools. The tools we will use for hypothesis testing, we already learned them, so there will be nothing new. And I already let you know that what problems I will work on with you. So I will probably work with problem number 1 in chapter 9, right? And also problem number 2 and 3 and I think 7. So what I will do is I will fully work on number 1 and number 3, and then number 2 and number 7 I will give you some time so that you yourself work on these problems. So I will give you maybe 5 minutes or 10 minutes, and then we can see whether you actually understand how to answer these hypothesis testing issues. Okay, now let's move on to the first problem in chapter 9.